So we saw in the previous one that the cross product multiplies two vectors and gives us a vector. So we know that, for example, the torque is R cross F. The magnitude of this is RF sine theta. Okay? But the thing is, torque is also a vector. So what is its direction? It's very easy for us to understand that if you have an object and you apply a force in that direction, it's easy for us to understand direction when it comes to things that are linear, right? But when things are rotating, it is a bit more complicated. And that's where the right-hand rule comes into play. We've already seen the right-hand rule when it comes to rotational velocity. If this object is spinning in that direction about that axis, we curl our fingers, if you remember, in that direction, and then our thumb points in the direction of the rotational velocity vector. Your thumb gives that rotational velocity a direction. Well, the same with torque. Torque, the way that we do it is we use the right-hand rule. We put our fingers in the direction of R and we curl it towards F, and so we have this kind of curl like that, and our thumb points in the direction of the torque. So the torque, the direction of the torque vector is always perpendicular to the plane of R and F, or of your two vectors that you are multiplying. Okay? So here again, you put your fingers in the direction of, if you say A cross B, you put your fingers in the direction of A and you curl it toward B, and your thumb will be in the direction of the vector product. Okay? Now what about the magnitude? As you can see, the magnitude of A cross B equals the area of a rectangle. If you've got, so we've discussed the direction now. Now the magnitude we know is AB sine theta. And if that is A, and that is vector B, for example, if this is radius, your R, and that's your force F, then the magnitude is equal to this rectangle, because it would be the magnitude of this length of the rectangle times that length over there, because that is B sine theta. Okay. All right, so maybe I can just go to the next page. Important. If two vectors are perpendicular, sine theta equals 0. Theta equals 90, and sine of 90 equals 1. So let's see here. What does this imply now, especially with regards to torque? If you've got an object again, and you've got you've got force pointing in some direction, and you've got your radius there, both of those are vectors, and you want to calculate the torque, we know that it's R cross F, okay, and it is then the magnitude, tau, the magnitude is RF sine theta. And so what this means is, it is taking this sine theta component is, it's either R times the perpendicular component, okay? So this is actually RF perpendicular, or it's perpendicular, R perpendicular times F. That's what this is doing. It gives you the magnitude, all right? So that's the one thing that I wanted to say. Okay, so this is the point, is that if your force is 90 degrees, then the sine of 90 is 1. So you're getting the maximum torque. out of that. Whereas if that theta is less, then you still need to calculate that component. Okay? So if the two vectors are in the same direction, then the vector product is 0. If they're perpendicular, that vector product would be a maximum of the 90 degrees. Okay. Hope you're not too confused.